The first 3 weeks of the eruption here in Hawaii, crazy things would happen in the middle of the night. A new fissure would open up and it would threaten a new neighborhood. Thousands of people were evacuated from their homes. I started the Hawaii Tracker Facebook group to help people understand what's going on and get their questions answered.
Hey, how's it going? We're live. This is Fissure 20.
We had hundreds of people all throughout the neighborhoods sending in videos, articles, and images. We spend a lot of time making sure the accurate information gets out.
This is live. There's still lava moving.
They weren't just sharing a story, they were helping their neighbor. If a family was being evacuated, the group would just jump in and help out. So it was huge. They were watching out for each other.
Hello everybody, thank you for coming. Thank you for the support from everybody.
As we go through this, we're growing closer together as a community. When tragedies like this strike, you really realize how much you need each other.
Aloha everyone, I'm geologist Philip Ong, here with Mr. Dane DuPont of HawaiiTracker.com, bringing you guys another Hawaiian Volcano Tracker update. Today is Thursday, April 20th, 2023, and we have still some elevated earthquake activity on Kilauea. Nothing on Mauna Loa, nothing about to happen this exact hour or anything like that, Dane, but it's been interesting to watch the progression over the last week here. How are you doing, and what have you been seeing?
Yeah, been doing pretty good. Definitely interesting today. Every time I check the tilt, it seems to be doing something different. Check it one in the morning, it's going up. Check it again, it's flat. Check it again later, it's going up again. Checking again just before we go live, it flattens off again. So pretty interesting, in terms of that signal.
Yeah, all little small scale variations there, and there's nothing jumping up today like we had last week. We'll follow up on that, of course, and talk about where we are. That did seem to be a sign of increased activity that's still ongoing now, but nothing breaking up. And yeah, we'll do a summary. We'll go through the usual progression. Dane will be taking questions and leading discussion on the chat. And anything else before we get into it, Dane?
No, I think that's it. Just if you do have any questions about Hawaiian volcanoes, drop them in the chat. We'll try and get to them at the end.
All right, thanks, Dane. So our Hawaiian volcano summary this week, starting off with Kilauea, where most of the action is happening. This is the map of the earthquakes for the last week. This is colored by depth, so red is the shallowest and orange is slightly deeper. All within this upper part of the crust where the magma in Kilauea moves and stored. So it's been a little more active than usual over the past week here. This is what it looks like. If we show you the plot of the tilt over the last month, you can see that there's been some variation with these inflation cycles. But overall, the recent pattern has been certainly one that's upwards. So it seems like the volcano is still swelling, tilting outwards in the ground, showing its earthquakes. The GPS is also expanding, and that's all showing signs of magma filling underground. It's still swelling there. This is a time-lapse view of the last week during the daytime from the USGS KW camera from HVO. And on the surface, this is what it's looked like. It's been pretty quiet. Still a lot of degassing, fuming happening there. Occasional rain shower coming through and everything gets fogged out and steamy. But otherwise quiet on the surface as far as we can tell. Here is, for comparison, earthquakes on Mauna Loa. So we're currently all the way over here. This is the last year of earthquakes. So Mauna Loa is still in this post-eruption phase. Everything's normal with Mauna Loa. Nothing like what we saw, the ramping up last year and the pre-eruption activity. So nothing to worry about there. Just thought we'd keep that update going as well. And that's a quick summary for this week. What we will do here today is start with earthquakes. Put the earthquake caption on the board here, because that's been the focus of all the recent changes on Kilauea here, right? So here, island-wide, maybe I zoomed it in too fast. Not a whole lot of earthquakes. This is just a last day here. There's one on Mauna Loa, but nothing alarming as far as its continuing settling there. Our Pahala cluster is still going strong. Otherwise, our actions here in Kilauea. So this is just today. Zooming in here, most of these are around Kilauea summit. There is the caldera of Kilauea. There's still these earthquakes off to the northwest where we've seen them by the campground before, flare off when a whole magma reservoir is getting full and getting ready to pop at some point, right? Usually more than this earthquakes, but sometimes we've seen flurries of large numbers of earthquakes here. A little bit here towards the southwest in this upper southwest rift zone connector that goes right through here, something like that. And also into this Kauai fault zone. So let me put the settings here and change this to the last 7 days. And then it updates. So you have a more complete picture here what that actually looks like. So it's interesting how they seem to kind of cluster in several different spots. Not quite clear exactly what's happening there, if it's adjustments of different blocks and different friction zones that are catching and flaring off these earthquake sets. But interesting to note that they're largely in the south part of the caldera here, with only a few northwest in that campground area that we mentioned before. So that's the pattern as it looks right now. Nothing happening at that alarming a rate. You can see our most recent earthquake is actually a 2.2 over here at that far tip of that southwest rift connector down in there. If I sort it by the largest ones, so you can see the ones that have occurred here. There's a 2.7 that was part of that campground cluster there. That was early this morning at 5 in the morning, and followed by a 2.5. Actually preceded by 2.5 earlier in the day. That was over here in this intermediate zone between that southwest rift connector and the south part of Kilauea caldera. 2.5, that was a couple of days ago. And days before that, another 2.5. So those are the largest ones. You can see there's nothing really huge yet, but it's enough that we've seen earthquakes of just slightly larger size than this set off these events where it can break to the surface through some weakness that's already there. And we know that the whole area is weakened post-2018 collapse. So largely repaired in that center collapse zone. And we know that as magma refilled, it was filling some of those cracks, but it seems like it might still be adjusting and pushing things and refilling and making some elbow room for itself is one way of thinking of it there, all underground in this area. So those are the earthquakes for the week here. Let's switch over to some of the monitoring signals. Let's start off with the USGS HVO updates for this week. And on Tuesday, the regular weekly update was scheduled to come out, so they issued that. We haven't changed our alert level advisory aviation code yellow. That still remained consistent for the last week here. And they note that in the summary, there's not erupting, no significant changes, no lava. However, when you go into the summit observations, they do note that seismicity over the past week was at background levels, with a slight increase in earthquake counts beneath Kilauea summit during 2 small earthquake swarms. Both swarms included approximately 30 micro-earthquakes, smaller than magnitude 2, detected over 12 hours at a depth of half mile or 1 kilometer, and centered under Halemaumau crater. The first swarm they note occurred Thursday, April 13th, and the second, Sunday, April 16th. 13th and the 16th. Sunday's swarm progressed into slightly increased seismicity in the South Caldera on Monday morning, and each swarm was associated with 2 to 3 microradians of inflation recorded on Wikahuna summit tiltmeter. All other streams remain normal, SO2 low. Most recent SO2 emission rate is approximately 110 tons per day on April 14th. So that is interesting, April 14th measurement. Otherwise, everything is standard here in the rest of the update. However, today, the USGS put out a status report at 1:16 p.m., noting that Kilauea is still not erupting. However, monitoring shows pulses of elevated rates of earthquake activity beneath the summit region. Small flurries of earthquakes have occurred irregularly beneath Halemaumau, Kankakoi crater, and along the southern end of Kilauea caldera since early morning hours of Sunday the 16th. The initial increase in seismicity was accompanied by minor ground inflation, but since then deformation rates have been relatively low across Kilauea summit. Gas emissions remain low, reflecting the current lack of activity in eruptive activity at the summit. No significant activity has been observed in either the east or southwest rift zones, so it's still summit only, but they're noting the seismicity, and here is the long and short of it. It's possible that an intrusion of magma beneath a surface eruption of lava on a surface may occur at Kilauea summit with little to no warning. Thus, beginning tomorrow, Friday, April 21st, HVO will be returning to daily updates of Kilauea volcano, reflecting the elevated level of unrest. And so elevated level of unrest being noted here. And otherwise, the color code and advisory level remains advisory yellow. Additional messages will be issued as merited by activity, otherwise tomorrow. So this does seem like they're leaving the door open that if something were to happen even tonight, they could come back and get back on it, and they may be getting into some kind of watch status there. Catch whatever is building up towards an eruption, although it might still be a while. We've seen these things ramp up pretty quickly with very little warning, but they've also just kind of flared off underground sometimes for weeks or a month at a time. So it's not quite clear how soon it'll come, but the signs are, for the moment, looking promising. That, yeah, that summit activity will either be resumed, or you might have just an intrusion underground, or you might possibly have it work its way towards a new opening somewhere. Of all those, it seems like filling underground and an intrusion is the most likely, because it takes extra force to then work your way towards the surface as well. So most likely thing is an intrusion, and then if it actually builds enough pressure and the longer it goes on, then you have a chance of actually building towards an eruption. So we'll see. That's the monitoring update. If you look at the graphs, here is the tilt for the last month as we just described in our summary. But looking a little more detail, it's interesting to note the different possibilities that exist here, right? One thing to just look at is the pattern of the peaks and the valleys of the tilt here. So it's hard to tell exactly, but one's off the graph, let's call it there. But we think we match the peaks of these deflation inflation cycles up here. Seems like one of these was a little lower. It goes something like that. You maybe see a slight rise. You match the bases as well. Similar kind of thing. And if you come up to above on the most recent part of the graph, it looks like more clearly it's going upwards. Hard to tell exactly how accurate that line is when you don't have a lot of peaks on this side. But likewise, you could do the same with the troughs and come up with something like that, right? So there's really this gap in the middle right here where there's a change. The USGS has noted that on the 16th, which is here, and on the 13th, which is here, they saw these increases in seismicity there and there, but that corresponded to these upswings in the deflation inflation. Let's clear the screen here. So these two upswing areas where we saw these increased earthquakes. However, it looks like, depending on how you look at it, if you consider this to be part of the baseline of that deflationary cycle here, then potentially you had an offset occur from here to here, right? You could actually have had this thing go into a deflation, and in theory it might have stayed deflation and gone to inflation here. So your offset would be this difference you see right there, which occurred sometime between maybe the 10th and 11th or so, 10th to the 12th, somewhere in that range, kind of before those earthquakes. And if so, you had that kind of movement of magma towards that shallower part of the volcano, not really towards the surface. It hadn't quite got shallow enough to put out any gas. It could be moving underground upwards, while the bottom part, the deeper part, is actually generating the deflation-inflation cycle signal. Still have some post coming upwards, and then the deflation-inflation comes back up, and that's when the pressure really hits the volcano because of that extra inflationary cycle there. That's one possibility. So you see it here, then it goes back into deflation-inflation and does it again when it's inflating once again. And we actually have not deflated to reinflate since then to see increased activity, but we've actually maintained this high activity at this high level here, right, for the last few days. So that is interesting to note there too. So you could note that, you could consider that, as USGS said, that right when the earthquakes are occurring is the actual inflationary part of magma movement there towards shallower parts. But I might be equally convinced that it was actually happened earlier over here between the 10th and the 12th or so, somewhere in there. And then it resumed its regular inflation cycle, deflation, inflation again. But we have this offset now. So that's a little interesting to note. If that is the case, it's a little more complex. Obviously, it's not the simplest explanation. It requires having those two magma chambers at different depths and having different signals. And but that's one way to look at it. In addition to having seen this maybe be the top of the deflation inflation, and then continuing to rise, and then having this be a big jump, and then this be a resumption jump after the deflation too. Either way, it's all showing the volcano is stressed, and how tricky these signals can be to untangle when they're overlapping like this. So moving on to the earthquakes. We've talked earthquakes already, but earthquake counts, earthquakes per day here on the left, and this is the last month on the bottom. So here's 3 of the last 4 days, registering over 80 earthquakes per day. Is that level right there? I haven't quite finished today yet. The other day was 60 earthquakes per day yesterday. There was one, if you go back to within the last week, that might have hit 50, but that's the lowest, was 50 per day. Otherwise, we're over 60 and 3 days over 80 up here. If you compare the rest of the month going back to mid-March back there, you see that the maximum values were around 60 or so, maybe one around 70, but some days quite a lot lower as well. So maybe if I just eyeball it, the average might be somewhere in there, and the average is now somewhere up here. So it's not a doubling or anything like that, but it's definitely stepped up. And this was that first pulse right there. That was a second pulse right there, and this is a continuing activity happening here, as you can see it relating to the graph above there. So nothing really extraordinary there, right? We've seen much larger flurries of earthquakes and elevated levels of earthquakes than this, but relatively speaking, it does seem like it's building upwards, right? And who knows how strong that whole reservoir system is, and how high they'll actually peak before bursting to the surface. And that's why the USGS warning of there could be very little warning leading up to it. It's good to keep in mind. So this down here is another view of the earthquakes. This is colored by depth once again. And once again, you have the same month of time here on the left, but depth here on the left, right? You can see that this darker blue band at the bottom here is the deep Pahala earthquakes, and they're occurring pretty steady. You see there are some variations of those create a few little gaps like there and there and there. But overall, it's fairly regular. If you look at the concentration on the top, though, among this shallower, close to the surface earthquakes, you see that for a lot of the month, they were occurring at a decent background level there. And then here, they actually have a pause. Right? There's a gap right there. And then a second gap, it's hard to see. It's not quite as long or clear gap, but somewhere right in there as well. And that's what corresponds to, if you look up here, right, that lull in the earthquake counts, and that lull after that first flurry that occurred where we were live last week. So that's the variation. It's a little bit harder to see in the month format, but let's take all that data and plot it out on a map. And there it is, these earthquakes being caught by that plot. Here is the main action at Kilauea Summit, where you can see that large density of earthquakes is showing everything that's been shaking over the last month. And clearly it's this region all through here. It's maybe outlining that affected area of where magma might be moving and pushing rock and breaking rock, or right next to it where the rock is moving to adjust to get out of the way. And you see still that summit area and upper southwest rift zone right through there. And you can also see in the last month that there are these two big yellow dots, a little bit deeper, but all the shallower south flank activity. And this is a decent amount of south flank activity in this upper part of it. Maybe upper part's not the best term, but like, you know, this area that's most directly seaward of the summit right there, as opposed to this like lower east rift zone area right through here, right, which also has south flank, but not as active. And some activity still occurring over here, but not as dense as what you see in this segment that's just seaward of the summit here. There's a big purple one that's a much deeper one, but the reason I'm putting these out in a little more detail is because over the last month there's been enough activity that we can actually see in this plot. This is now a plot showing depth against longitude, right? So the way that this works is you take this map above here and you squish everything together. So you take everything and you squish it down. You're going to capture everything that's been projected all onto one surface from that direction, right? So it's not exactly a cross section, but it's more of a synthesis, a compilation of all that data. So there it is. There is that deep Pahala zone occurring over here. Zoom it in. There's that deep Pahala cluster right through there. You can see there's one deep earthquake in that area. But there's also some of these deeper earthquakes over the last month that are more further to the east, right? And Kilauea is actually right here. We can see this is that conduit system coming up right there, right through there, right? There's some green ones, there's some yellow ones, and then kind of leading up. And then there is that shallow magma reservoir system / rift zone, which goes like that, like something like that, more or less. Right? There's our zone. It's a little bit mushroom shaped, and you actually could draw all the way down to here. You probably have some seismic, so some zones that don't actually generate earthquakes because the pipeline is the conduit is such that the magma can move through without breaking anything. So there it is. And then it's thought that there could be a connection that comes over in this direction as well. Right? The magma is coming up here, feeding its way this way, then feeding its way up, and then feeding its way both directions there. Summit, right? That's what's interesting to look at. And then if we scroll over further this way, there's another set of earthquakes that are all over here, including these two big yellow ones, right? That's part of that south flank sequence. So this is all that south flank. So as a volcano fills with magma over here, this side of it is free to the ocean. This side over here goes towards Mauna Loa, so it's not free, it's basically stuck. So the side that moves is this one, and as it moves away, it generates these earthquakes in the south flank there to accommodate that expansion. And don't usually go into that much detail in these projections, but today it happens to light up quite nicely to show that structure, so I thought it'd be worth it. And there's that random one a little further over, deeper purple one over here. And that one you can see is not directly anywhere near any of the other magma signals. Once again, you can imagine that as this south flank is getting pushed away, that this balance of mass on this near the surface is shifting further east, and you might cause adjustments deeper down. And that's what I would guess this is a category of this earthquake. So that's a little bit of the last month. Now if we once again zoom out to the last week, there is that population once again. I've shown this enough, so I won't go into any more detail, but there it is, those similar kind of clusters. And not as much in the south flank, and normal level is there at the Hala region as well. There it is in cross-section now. If you look at the cross-section here, you can see that what's mostly lighting up is that upper shallow section right through there, right? So you can see that likely in the last 3 weeks, all the other earthquakes that are missing is where they were. Was that migration of magma likely up into the volcano, the recharging of it, and now it's just trying to spread out and pushing in its upper parts there. That's kind of the state it's in. And still some south flank action, but not as much adjustment there. There it is, looking in more detail, depth versus time for the last week only. So that first flurry of earthquakes would have been off screen over here, and actually ending right through here. And then there's one of our gaps of less earthquakes right through there. And then here you see these flurries, these episodes, seismicity. There's one, a little bit of a gap, and there's another one right there. Have slight gap, but maybe not even gapping. It's just slowing slightly here, and that's where the USGS decides to bump to daily updates right in here. So in comparison, 1 week of earthquakes, 1 week of tilt here below. There is that last inflation cycle right here, so you can see we're coming out of it. This was the building up part right here, just off the screen. And then the deflation, and then reinflation right through here. Come up, you see that's when these earthquakes begin once again as well, in large quantities. And since then, this area right through here might be a little bit of the deflationary pulse. And that's a little bit where you see that gap as well. So you see it's interesting to see how sensitive it is and how well connected it actually is, where every little change in the pressure is causing earthquake flurries to pop off here, right? That shows it's getting close. So the last thing to note, looking towards the surface, the gas is still low. The USGS did restore the laser rangefinders to summit lava depth. So we now have a plot here for the last week, and what you can see, I zoom it way in, is basically we're starting off at 388.5-ish, and we're ending at exactly maybe slightly lower there. Yeah, right. So it's not like lava is coming in beneath the crust and lifting the crust or causing it to bulge or do anything funny like that. There's no sign of that at all. No sign of the gas. Here's the last month of lava. There's the data outage right through there. So right through here, data outage. So you can see the line was there just under 390 and maybe slightly lower over here actually, right? This side, slightly below the dash line right there compared to on this side where it starts, showing that expected trend of it actually settling as it cools and degasses still a bit. And for comparison, the last month of SO2 at the summit, only two values, 110 and 109 tons per day. It's important to look at the scale. Sometimes these things are really blown up like this, right? Where it looks like a big difference between this plot, that data point, and that one is only a 1 ton per day difference. It's really the same data point, just taken on the 14th and earlier on the 5th here. So pretty constant emissions. It's really easier to see if we zoom out to the last year of SO2. Here it is on the top. And there's those two measurements down here in the bottom right. So very low values. This was our most recent pulse of eruption beginning in January, where it spiked up to 14,000 tons per day and then came all the way down. And here, by the beginning of March, it was getting close to zero. And then that's when the lava stopped flowing. And here we are pretty much near that zero line at that background level that's Kilauea. And different than we saw the tail off of the previous phase here. Right? So there it is, that 2021 to 22 phase that ended here as Mauna Loa started going. And then you'd almost consider that Mauna Loa may be interrupted while Kilauea is tailing off here, right? So she had a chance to recharge a little bit, but it wasn't that much. It only lasted these few months here, 4 months here, and then now we are back in this post-eruptive period here. But as we've been talking about, magma is still coming in and likely to resume again. Here is the whole last year of earthquakes, showing earthquakes per week as each bar graph here. And so you can see that our most recent week is climbing up the highest that we've seen for a while, really, since that build up in January. Hasn't quite reached that level yet, but it is exceeding what we're seeing as a background ever since lava stopped erupting, which was right through here, right? This is all eruptive phase through here, where it's just low values. Lava is coming out pretty efficiently, and not a whole lot of earthquake happening. It's more the background level. And then once it stopped coming out, it has a chance to build up pressure and quake, and that's what you see right here. And that's normal for that to occur and build up, but it should at some point peak higher, and that seems to hinting at doing that. Maybe not this week, but we'll see if the next week. And we see here prior to January, there were 3 weeks of that buildup. Seeing maybe one, and we'll see what happens here. GPS at the summit has bounced back up. So here is the line distance across Kilauea summit, and you can see it's taken that, it's still expanding there. And we go down to the Pu'u'o region at the Middle East Rift Zone. It's still holding fairly steady, not contracting as fast as it was before, so it's definitely slowed in that way. But it seems to be holding fairly steady there, and no major changes. And it's similar to what the story we showed you guys last week. If I actually come over to the GPS plots that we mentioned last week, looking at these vertical components at Wikahuna, how everything was sagging. Here we actually see that the signal bounced back up at Wikahuna, bounces back up at Byron's Ledge as well. Down here, bounces back up at Crater Rim as well, and bounces back up a little bit too down here in the southwest at the outlet. So resuming its previous trends there, while elsewhere you don't see that. And coming down just to reassure, at the Pu'o'o station, Jacuzzi still going downwards, and Pu'o'o still going downwards here as well. And that's what really matters in the long-term GPS. So one final note on the signals here. It does look, here is our Pu'o'o tilt meter for the last month, and it appears if you scroll here to the right, it's showing signs of life. So hopefully this comes back online. You can see that USGS has been out trying to get all their equipment back reconnected and getting upgraded and all of that. We'll talk about that more here shortly as well. So those are the monitoring signals for the week. So let's move it over to our observations here and show, that's the static, and let's show this loop. This is the last 24-hour loop from the USGS of thermal camera showing that West Vent Pond area right in here with that brightest pixels. And you see other zones of heat around this moat zone where the ooze-ups come up closer to the caldera wall over here, or to the crater wall, I should say, right? There's another zone of heat you see more or less in here and in here. This is kind of the area that surrounds that old west vent from the first phase of eruption, and we're keeping an eye out to see if there's any outgassing happening there. But nothing convincing anywhere apart from some unverified reports that maybe there is occasionally some lava visible popping up there, but nothing we've been able to actually verify with photographs or anything like that. So interesting to note, and keep an eye on here on the thermal cameras. This camera is kind of zoomed in, right? So you don't really see all the far edges of the crater all through here. So if something does ramp up, you might have to switch over to the KW camera. That's what we were showing earlier here. Last view, the last week of the surface of Kilauea. Catching all the edges of that hardened lava lake. It still has liquid underneath there. So some other visuals. The USGS did put out several photo releases this week. This one comes from in the last week, April 14th. There's a panoramic view of Kilauea summit with that same crested over lava area, and West Vent Pond, a little higher resolution here, maybe a little easier to see. So with that area where you see that glow coming from is this pit and area right through here. This is the old vent cone, and that vent basin that was a lava lake that was circulating is over here. That's where everything is oriented. There is that remains of that central large island that formed early in 2022. And here in the background is the remains of that eastern basin that was filling most recently in January. So there's a landscape. I'm going to cycle through here, a little bit closer view of that zoomed in island and that basin behind it. Closer view of that west vent cone and that pit right through there that has that zone of heat. One more of the basin itself, where the lava was circulating when the lava first came out in 2021 and 2022, was coming out from this direction and flowing back under the crust that way. And when it reactivated in 2023, it came out from this side and circulated back to that direction. But it still seems like the deepest connection to the underneath the crust, where it's still hot, is a little further off this way where that lake was I showed you guys. And noting as well steam on the eastern side of that lava lake area. This is that old downdrop block here. So this is all the old lava that collapsed in 2018. And this was the edge of a big pit that the lava's filled it all the way up to getting close to the tip of it here. This particular spot still showing quite a lot of fume, which is showing up on some of the webcams. Note that shortly here. And still noting that old piece of crater rim drive that collapsed in, was sort of a road visible right through there, and some outgassing happening below it. So otherwise, there are some older photographs from back in March of USGS geophysicists performing their annual gravity survey. They have these portable gravimeters that they come and deploy, and here they are collecting data across the caldera floor. They can measure the change in force and gravity to 1 in 1 billionth of the force you feel every day. There they are, another part of that caldera floor showing a gravity survey. And that's that first data dump right there, showing some of the fieldwork ongoing as activity has been at a lull at the surface here. So also ongoing is this seismic deployment, right? We talked about the Volcano Watch, might have been a couple weeks ago, where they're dropping all these different seismic nodes. I believe 1,800, nearly 2,000 of these seismic nodes all over the volcano, and coming around with a ground size pounder truck on the roads to pound the ground and listen to all the echoes of the reflections of that energy, so they can image the volcano, where magma is, where the fault lines are, where the base of the volcano is against that old ocean crust. All those things they're trying to manage. So you can imagine 2,000 is a lot. Here is the operation. Looks like they have extra staff on hand. A lot of helicopters booked where they are at the landing zone in the park, with all of these bags lined up here, and different view of all the equipment, all packed and organized to be deployed in different parts of the volcano. Here's what one of those cases looks like with one of these nodes per bay right in here. Here they are after having been dropped off at a location in the field, and most of these are actually getting hiked around by the team of USGS scientists, but some of the harder to reach areas are getting helicopter support. So in that case, they're dropping them off. There they are, looking for the locations, taking their notes, installing. There's got to be good contact between the node and the ground surface right there. So what they'll do is take this as a sandbag, put it on top to keep it way down so the thing has a good contact and all that energy can actually be detected by the instrument. It's connected by this wire to this battery pack. So the battery pack's designed to last these 2 to 3 months. It's going to take them to leave them out, pound the ground, and then come back and collect them all. And so for this reason, you might see extra equipment all across the volcano. You might see extra staff scientists wearing orange shirts hiking around the volcano as well. And at some point in May, you might see the truck driving around pounding the ground too. We'll get to that here in a minute, but another view of that, measuring the orientation of the node and noting that in the notes. And some different views of the caldera floor. Unai Pali here. Here's a view of a scientist hiking down into Pauahi crater, a place that do not go very frequently, but here they are hiking in and deploying seismic node down there. And yep, there it is again in Pauahi crater. Installation of that one, and another one, a scientist down in Hiaka crater. And what you can see is that they actually landed a helicopter down on the floor of the crater, and it might still have its blades spinning. It's hard to tell from the photograph here. But in the meantime, you can see here's a scientist at the bottom of the Hiaka crater deploying a seismic node. So most nodes deployed by scientists hiking. However, some nodes are being placed in areas difficult to access, such as craters, require helicopter support. So there's that seismic deployment. There's a whole website for this seismic imaging project in Kilauea, which has a lot of that standard information. All the Volcano Watch articles are listed back here, and image articles, multimedia sets. But up here in the overview, I'll scroll down, and there is that vibro-sized truck that pounds the ground to make those echoes we discussed before. But what I want to show you guys is this map. So here's a map of the actual planned routes. The yellow dots are where they're going to drive the truck and pound the ground. So not just inside the national park, but it looks like they're going to drive it from Highway 11 outside Volcano Village up the highway. They're going to drive it down, it looks like, 2 of the roads here in Volcano Village as well. 2 of the closer roads in the village. That might be the right road, perhaps, back there. And then within a park, and also here's a golf course, so up the golf course road as well. You're driving up there, and along Highway 11, within park boundaries over here on Highway 11 as well. Otherwise, it's Crater Rim Drive. They're actually going as far as a museum, it looks like, and all the way around. They're going to go down into that old part of Crater Rim. That's Waldron's Ledge area. That's kind of closed off to most traffic. Maybe that's that management area in there. But then they're also going to come down the escape road, notably, right? This is that kind of gravel road, dirt and gravel road, all the way down to Maunaloa, and then also down Craters Road as well, and about as far as Maunaloa by the looks of it as well. There. Further, they're going to go down the Hilanapali Road over the Kauai Fault Zone area to the southwest over here. So those are the truck driving locations where they're going to drive the truck. And areas where the nodes are going to be deployed is this shaded area everywhere else here. So you can see it's focused on Kilauea Summit and surrounding areas. Excuse me.
You're right there, Phil. Right. Yeah, take your time. It's a wider area than I thought they were going to be covering, you know, with the ground and pound truck. Also, apparently, it's called a whacker for if it was a compaction truck.
Well, yeah, is that industry lingo there, the whacker?
And the whacker.
Not the vibro size. That sounds way more professional.
Right.
So yeah, that's the area. Nothing down on the lower East Rift. It's all around Kilauea Summit. So there's a seismic node area and an area where they're driving the trucks. And otherwise, you can see what they're looking for. They can help reveal features like magma, dense accumulations of olivine crystals. So that whole area of crystal mush, those settling zones are something that they can hopefully image as well. That's part of the question in Kilauea. Connections between the Summit Magma Reservoir and the East Rift Zone, which is something that's always been a question exactly how that works. Right, the major fault lines, and where the base of Kilauea contacts underlying ocean crest. Additionally, they'll collect data to build a new 3D velocity model of the structure summit, so that's going to help improve earthquake locations and all of that. However, how long will it take? The study will involve at least 3 years of data analysis and interpretation and result in reports on topics described. Right, so about 3 years of analysis. It doesn't mean that all the data will take 3 years to come out. You might have some of it come out in a year, then a little bit more in the next year, a little bit more. We'll have to wait and see. So with that is the seismic node project here this summer.
Apparently, Whacker is the brand name of that type of truck, or the manufacturer.
Okay, that makes sense.
Mm.
So then they rebranded it to Vibro Size, huh?
Right.
That sounds probably a good call if you're the U.S. government. So last data set here, another equipment upgrade on Hualalai. HVO upgrades the Hualalai repeater and installs new webcam April 19th, 2023, yesterday. So during that week of April 10th, HVO upgraded the Hualalai repeater station and installed a new webcam looking at the northwest flank of Mauna Loa. There's Mauna Loa back there, looks like. Mauna Kea back there, and here they are walking on Hualalai. Reaching the station, underneath a solar panel, they have all these different boxes. And what they're doing is upgrading the batteries, replacing the batteries, and upgrading them to lithium batteries, which means reconfiguring all the electronics in there. So they've actually remove the electronics board, replaced it with a new 48-volt system electronics board as part of this host station upgrade. You can see there's our batteries in the case. They're having to drill new holes in all of the mounts, install new electric boxes, housings for the camera, connection points in through here, and then check for signals, check that data is getting pushed through. You can see it took them all day. It went from nice and clear when they hiked in to totally clouded over here. And cold, likely, right? They're up in the cloud forest here, but bundled up and continuing to install. A lot of hands on deck here. And there's the batteries in the case. Everything getting wired in and dialed in there. Another one, there's a better view of the batteries in the case. This is an elevation of 7,090 feet on the southeast side of Hawaii, elevation of 2,160 meters. And there is what that finished station now looks like. Repeater station is a station that is bouncing a signal from one part of the island to another part of the island, so everything's going to get back towards the HVO central network, which will be in Hilo, right? But used to be all focused at the Wikahuna area in a national park. Some areas you can't see directly line of sight because there's a giant mountain in the way. So in that case, you got to bounce the signal from where you are to a mountain you can see, have it bounce to another mountain, and then down to where it needs to go eventually. So that's why you see all these different antennas. And that's the purpose of it. So here's a new HL cam, as it's now called. There is a current live view is in a cloud right here. Earlier it was a little clearer. I can get it to show earlier. Here's the last 24 hours cycling through, so nighttime view there. And then here it should come. There it is. Southwest side of Mauna Loa. A little bit of snow, and then here comes the cloud. So that's the new HL cam. All right, so that's all of our visuals. We'll do a quick update on what there is to see, which is all these changes on the surface, the fuming and the steaming. However, our lava viewing report is that there is no lava or nighttime glow visible from any overlooks, as stated here in a. So if conditions do change, as they can at any time, then you can check for guidance at the park or on the website as well. I'd like to come up and see what's going on. So it's short and sweet here, not a lot to report as far as viewing until something does pop up. And we'll know it's going to be epic for a short time, and then hopefully still something to see for a while afterwards. So moving on to our volcanic hazard summary, which as usual is the gas. Here is that VOG mapping and projection project showing our emission source of Kilauea at 100 tons per day and where that VOG might be moving and collecting. And you see it's largely, see a little bit coming into the saddle around Mauna Loa's northeast flank, but otherwise it's catching here in the upper slopes of Pahala, maybe making its way down towards South Kona as well. But otherwise, still can be, a nuisance or more than a nuisance, a serious hazard for someone who's sensitive. But the levels are fairly low compared to what we've seen in the past, still exceeding what would be a factory at that location, right? That's unregulated, putting out as much gas as it wants to. Even that low background level is enough that it would be fined by the EPA if it was actual human construction here. That's never going to work, of course, so we just deal with it. But that's the background, is that there's always some VOG around, even at times without eruptions. Just locally, though, here's our Purple Air Citizen Science Monitoring Network. You can see it's green everywhere on this capture from today. So not a lot happening there, and we'll check the national park as usual. Summary presently is everything's in the green. Not very strong wind, only 6 miles an hour there. So I'd like to go to the charts to check out the history. So here they come. SO2 on the left, particulate matter 2.5 on the right. You can see everything's in the green all the way down. However, there have been times when I checked this morning, I was noting that the visitor center PM 2.5 was looking a little high. So I have that. It was just a small little spike, and it was all still below the national standard for PM 2.5. I have lost the graph that showed that more detail. Nothing alarming, and there could be other causes of 2.5 that are not volcanic, such as vehicles nearby or blowing dust, that kind of thing. So it's really the SO2 that's more important, but this also gives you a sense of when it's actually VOG. It does show up here as well. In any case, still mostly green most of the time. Occasionally, if there's some changes, you can check it apart. All right, so we'll move on to Mauna Loa then. And as mentioned, Mauna Loa is still quiet, no major changes there, no reason for concern. Here's a tilt for the last month, showing that upward trend, maybe a slight slowing, resuming, and seems like it's still going. So not a whole lot of change in the tilt there. You do see these wiggles up and down, or that day and night variation here. Seems like sometimes they do kind of flatten out, like there and there and there. Not exactly clear to me what this is. It might just be, it might be snow. It might be some weather up there or something like that. Some other change in the cycle. But nothing major, right? If you actually look at the Mauna Loa webcams, this is a little side adventure here. The Mauna Loa webcams, the one at the summit is frozen back at March 8th, so it's showing snow up there, but it's not the current snow that we see right now. Go to the thermal, and it's frozen back on March 1st, so it's not of any use either. Okay, let's move to the South Rim MO. This is frozen back in 2022 in October. Not going to help us either. South Pit frozen back in October 2022. So good thing we have a new one, but here we are finally from Kilauea. We have a currently timed view from the M1 cam, but no view because of the clouds. Mauna Kea is current as well. Kea current as well. Northwest flank there, and can't really see much anywhere else. Well, here we are. But there is some snow up there, as we noted earlier on that HL camera and that view from earlier today. So maybe there's something like that going on up there, but nothing major, nothing to be alarmed about. More important, earthquake rates are here. Earthquakes per day. The maximum value on this graph is 9, so this is actually a couple of 8s up here, so very low values. Looks like a lot of variation, only because the scale is so zoomed in here. Really, as we showed at the top, this is the status we're in, very low background levels compared to what we saw much of the last year, or much of the last 5 years, in fact, as well. So still building, no real change. Everything is as expected, and for the last month of earthquakes on Mauna Loa summit, you can see here they are, very small ones, more so on the southeast than more dispersed to the northwest. But compared to Kilauea, it's really not a whole lot going on, even to Mauna Loa as it was happening last year. So that's Mauna Loa's update. We do have a volcano watch this week that does talk about Mauna Loa as well, but this is a look back at the 2022 eruption, and in particular, the messaging and addressing this question: did lava flow out of Mauna Loa's southern caldera in 2022? Now, I'm going to do what I feel USGS did not do and just answer the question directly and simply and say yes. Yes, it did. Right? They look like, as we go through this, looks like they start defending themselves of why they said no early on, and then it seems like they concede that it actually did, but they don't actually ever state that explicitly there. So we'll see what it actually says here. They do note the eruption began just before midnight, 11:21 p.m. on the 27th. First fissures visible on the caldera floor and webcams. However, activity propagated south outside of field webcams in initial hours of activity. Right? Maybe this is a little hint of why there's a new webcam on Hawaii now, which they would have had a view at that point in time. So they put out this map, and since it's the first thing on here, we'll look at it first. In red are the fissure vents, which extend. Here is the one that was erupting. This is fissure 4 and fissure 3 from the northeast. I put out most of the lava was over here. But this whole northeast rift zone phase was what followed at about 6 a.m. or so, and really the other phase down here to the the bottom, it was that first phase of eruption. So there is the fissure within Mokuaweo'oweo, that inner caldera, the summit of Mauna Loa. However, the USGS for a while, we've been trying to explain this as well, defines a summit as a different region where the outer caldera faults mark the landscape, and that's shown by this gray line right through here, there, in that direction over there. Solid lines where it's exposed and visible, and dashed lines all through here where it's inferred, but it's buried under lava, so you can't really see exactly where it is. I can't tell if it really goes here, if it goes a little this way, if it goes a little this way. A little hard to tell. However, they draw it right here because there are 3 pit craters. One's right there, one's right there, there. They're thought to be all within this greater caldera area, part of the summit complex. And so, in detail, this thing will let me zoom in more. There it is. There is that inferred contact right there. And here, they're clearly showing a fissure outside that Great Caldera area, actually into the southwest rift zone of Mauna Loa. So there was a fissure in the very upper part of Mauna Loa's southwest rift by this definition of using this dotted line right through. And that is in fact what they say in a few paragraphs down. However, they start off by saying, official statements from HVO noted initial events were within the caldera. However, lava flows were reported visible from Kona. Indeed, Kona residents could see lava flows descending the western flank of the volcano and were concerned, feeling the lava was outside of the caldera. In hindsight, it seems appropriate to explain what HVO knew in the first few minutes of the eruption, and why Kona residents were able to see the first lava flows. So they are just noting that what HVO knew in the first few minutes was not that it was going in the southwest rift. And maybe if they had a camera or better mapping that they could have done on the fly and not after the fact, they would have realized that it actually had done that. However, early on, that was all the messaging, was that it had not gone into the southwest rift and was still within the caldera. They note people familiar with Mokuaweo'oweo, the inner caldera at Mauna Loa. However, there's an outer caldera, indicating less obvious geologic faults that designate a larger area. Also true at Kilauea. Most people think of Kilauea Pele as a giant crater that the crater rim drive mostly in circles, but the outer caldera actually extends outside of Highway 11 on the opposite side of the park entrance there. So this is something we discussed before as well. And you can see that here, as I state, the southern caldera is buried, 3 pits, as we mentioned. And here, this is where it gets interesting again. The western rim of the outer caldera coincides with the inner caldera. They have not found an extension of faults to the west. Right, so let me point this out on a map here. What they're saying is, in relation to Mokuaweo'oweo, which is this pit right through here, right, you can see that there's a gap to the east, but it actually overlaps here on the west. Right, so there's actually this bluff. So that's why people from Kona, looking from this direction, are wondering, well, if there's a cliff there, and I see lava flowing towards me, then that's not good. Right? It must have gone over the cliff. But in fact, it's just slightly down to the side over here, where lava was flowing downhill, right, in this direction. But it was doing so where there was not a cliff. Here is that last piece of cliff, is right through here, and also right through here. So back to their text here. The approximate boundary between a caldera and a southwest rift zone is where these circumferential cracks cross the rift zone. Fissures that cross these circumferential cracks would indicate that the eruption is migrating into a rift zone. Sometimes fissures run right up to the outer caldera boundary and then head in the opposite direction, as happened during eruptions in 35, 42, and 84, and really also in 2023, right, if you think about it. So just to review on a map once again, it actually started in here and migrated that way and this way at the same time, and kept going over here, and then it actually went all the way back this way and opened in this direction over there. So if it did hit this boundary, then it didn't actually bounce off, like it may have reduced. If you look at the actual amount of lava that came out from this piece of fissure that's just outside of that line, it's not a whole lot of lava compared to what you see up here, where there's a huge flow that actually went downhill. So maybe that is the correct location there. And there was some crossing occurring, but not very efficient, and most of it actually found it easier to go back the other direction, back to the northeast, right? that is possible. Not quite enough information to note there, but that's what they're talking about, is this intersection happening right through here. So this is an important concept because HVO stated initial 2022 fissures were restricted to the summit area. Yet overnight photographs from Kona showed lava flows descending the western slope. So how is this possible? Shouldn't lava be hidden from view by the western topographic edge of the caldera? I have more to say on this, but I'll maybe wait till we start discussing it, Dane, here, and just finish up the text. HVO's use of the phrase summit region may have caused confusion for some residents who thought HVO was referring to the inner caldera. The flows seen from Kona were coming from 1.8 miles of fissures in the south outer caldera. When lava is erupting from this area, is visible because there are no major caldera walls obscuring the view of the western flank. And here, this is key. Here's where they finally can see that that's actually true. Later mapping revealed that 2 kilometers, 1.2 miles of fissures extended from the outer caldera into the uppermost extent of the southwest rift zone, with minor lava being emitted from those fissures. Right? So their state, right? Mapping revealed fissures extended into the uppermost southwest rift zone. Right, that's what that says right there. In total, just put it in context, that was 1.2 miles. There was 5 miles of fissures across the caldera floor, but you add the northeast rift zone, and that jumps up to 11 miles, 17 kilometers of fissures across the southwest rift zone, summit, and northeast rift zone there. So that's the USGS article. The one thing I'll add, just real quick before I give it to you, Dane, I know you have a lot you want to say about this.
There's a lot to add.
Yeah, but I'll just shut up for a minute here. But the last thing I was going to say is that I think it misses the point a little bit to talk about overnight photographs showing flows descending the western slope. There was a moment there between, what was it, like midnight and 1 a.m. or so, where it looked like lava was actually, the areas of bright glow from the mountain were progressing much faster than lava flow, right? And so I think people were able to see the fissure actually propagating down towards them outside of the caldera area. And they saw that change within 15 to 20 minutes. So I saw one photograph, some people were sending us photographs of, look, it's coming towards us, and 15 minutes later, like, look how much further it is in a photograph. How could that be if it's actually lava flowing? It makes more sense to be a crack opening and lava coming out of the crack, but getting squeezed out underground and then flowing downhill. And it's just more complicated than they're really giving credit for here. So that said, I'll pass it over to you, Dane. Take it away, whatever you'd like to add.
All right. So the reason why this is annoying to me is because USGS HVO on the USGS Volcano social media page decided that it would be a good idea to call out Akaika Marzo by name, right, for saying that the eruption had entered the southwest rift zone. And it turns out, by their own definition, he was right. Now, there's not going to be any admission of that ever happened type of thing, and I wouldn't be surprised if the thing got deleted type of, one of those comments. We've seen those before as well. On the night of the eruption, we were live streaming, and I was telling people that no, it's not in the southwest rift zone because I have a different definition of it, and it was told by, USGS HVO that it wasn't accurate. They were using this line, the Greater Caldera, where we were using more 12,000 feet roughly, which is in the same area, but it's a little more forgiving in that regard, right? Because we're not saying things like it comes right up to the line and bounces off or anything along those lines. It's just the general area of the summit, and that's just in that area, right? And again, this is the representation that I want to show is 12,000 with the little flow there. It's better. It's not perfect, but I'm not defining exactly 12,000, right? I'm like being flexible with it a little bit too in the summit region. That principle of summit region and then it goes into one rift or the other and not transitioning back is clean. But you have to account for that when Mauna Loa's summit erupts, it creates this multiple mile-long fissure basically that extends across the entire caldera, and just because the edge of that bleeds across this line doesn't mean all that much to me. I'm looking for the escalation that means that it's actually going into the rift zone, right? We know that that thing's going to open up wide, and so what if it crosses that boundary? It just showed that boundary is somewhat arbitrary. That's what this map shows to me, right? Yeah. You need to be somewhat flexible in it if you're going to say that it's summit first then rift zone. right? You have to be flexible in what is the summit, because if you start making these delineations, right, and then it goes outside of them, so what does it mean, right? Well, it needs to me, it needs to be a little more flexible on that kind of stuff. And it's important because we're telling people this is the sequence, right? And the sequence is pretty clean and it's pretty simple. But when it gets over that line and you're saying that this is the line, that creates issues. And then you can't call people out, in my opinion, being like, oh, well, it's across the line, basically, right? It's outside of the summit, as a layman, like, Kaika was doing, and he's just trying to help on the thing, right? So, that to me is just, if you're going to be talking about, we've been reading a bunch of articles about the social media trust, the USGS, it's like, we have to start somewhere, right? And this is not the proper approach to me. I mean, I'm glad that this delineation, this actual outline of the outer caldera, last time I asked, did not exist as a graphical layer, right? They're like, oh, well, you can see it from satellite imagery. It's like, but we're saying that this line's important. Shouldn't we show where the line is, right? And now we show the line all of a sudden and overlay it with the map of the eruption. It's like, oh, that's an issue. Right, immediately, oh guys, that breaks down the things we were saying. We got to go to 12K or something more broad, or else what's the point of this? What is the point of telling people this sequence if then we just break out of it on the initial thing and just go with that, right? So I like that they were saying, it's not in, it's summit only. We were saying the same but for different reasons, right? But I mean, it's important for people because people just, one of the things that was being told to people is during the preparation for the Mauna Loa eruption was basically, if you see lava coming, go ahead and evacuate. Well, they saw lava coming and they went ahead and evacuated, but that wasn't what they meant. They didn't mean to evacuate from a summit eruption, right? They meant the rift zone type stuff, but that gets lost in translation between these high-level PhDs and laymen that have no experience in the thing. It just gets completely lost, and they just go with what they were told. And then all of a sudden, Highway 11's jam-packed, without an evacuation order, and we're doing the thing, right? I don't know. I really have issues with that type thing, especially if they were right on it. It was been like, wow, great call. But then you mark it out, and it's like, what was the point of all that, right? To call that out and stuff like that. Sorry to go on a rant, but it's frustrating.
No, it is.
Right? It's like they want to talk about trust and all this kind of stuff, and it's like, why are you going to call out somebody like Kaika on something like that? Right? It's trivial. And your own map shows it. Type of thing.
We've had other run-ins that we'll have to get into in the future here, but like the overall thing is that they are willing to take credit for a lot of stuff, and they will never admit a shortcoming. It seems like, right? It seems like the bureaucratic model, right? You can't really admit that you did anything wrong. They could have done something better. They're just highlighting things that went well and writing them in such a way that's ambiguous, so it makes them look better. And like that's where I call BS, right? Like
right.
So yeah, it's frustrating. Like that in this article, they wouldn't come out and actually say, "Oops, we were wrong." It actually did go in there. There's no answer to the question. The article, the title of the article was a question, and there's no answer actually explicitly in there anywhere. It's left to someone to actually try to untangle. Is it actually yes? You start reading. If you only read the first two paragraphs, you might think, "Oh yeah, the answer is it didn't go outside of the summit." Then they sneak in the change of answer there at the end. So that's a little.
Oh no, it got me because I didn't look at the map. I just saw the map on my phone when I was reading the article, and just going through it. I'm like, oh, okay, yeah. So it abided by the thing. Great. Then it's just like, oh wait, I look at the map. No, it didn't. What are you guys showing me? Like, that's a weird dance you guys have going on with this one.
Yeah.
Right? Just admit, like, if you want people to earn people's trust, it's not by covering up the mistakes, right?
Yeah.
You gotta admit, like, hey, we got this wrong. Sorry, guys. Sorry, Kaika. Didn't mean to go down that road. But, it's frustrating because it's like we learned so much from 2018. And I feel like HVO learned a lot from 2018. But the people on the mainland did not learn those lessons. Perhaps something along those lines, because there's a break, I feel, and it's frustrating. We'll go into it more later, but just looking at this, it's again, why can't you just say that, oops, we done goofed on that one a little bit. We were right in principle, or we got the right call, but for the wrong reasons, or something along those lines.
They were giving the right information to the best of their ability of what they knew, and they just didn't know that it went out to didn't had crossed that boundary. They didn't know, there was no camera facing there. They didn't have anything in the air that they could see it. They just knew it wasn't further down the rift on their webcams, so they actually couldn't see anything, and they didn't know until several days later, right, when they actually got a satellite scan of the area, and as we showed during it at the time, like, oh look, there's a steaming crack over there, and hey look, there's a flow. It's actually way down here. How about that? But that phase had already passed. That was a few days afterwards. The phase had already passed, and we were already dealing with an eruption, so that kind of got just delayed until now, right?
Yep. It's I mean, I'm glad that they actually produced the outer caldera GIS layer, right? I'll take that, but I'm probably not going to use it next time, and I'll probably go back to 12,000 feet because it gives me the wiggle room, so I don't get caught on the fly on a live stream where I'm sitting there like, oh well, it crossed the line that I had previously said, so therefore it's a rift zone. Like, no, it needs to be flexible. Like it's cool, it's great that we have it, but that's not how I don't think it plays out in the real world type thing. In theory, sure, right? But you start adding the little bits, and then it starts creeping out, and you got to be flexible.
Yeah,
that's all I'm going to say on this. Rant over.
Let's leave it. Let's leave it for now. Yeah, that's this volcano watch from this week from USGS, revisiting this topic of Mauna Loa's southwest rift extending fissure here. And you can check that out on hawaiitracker.com if you want to read it in more detail beyond what we've shared here, which is already pretty detailed. So that's Mauna Loa. I'll just put up one slide for our community events here for National Park this week. This coming week is National Park Week, April 22nd to the 30th. So on Saturday the 22nd, entry is free for national parks nationwide. And here at Hawaii Volcanoes, there's a Journey at the Summit family event that's free. It's a role-playing quest where families receive an adventure pack with directions to activity stations in the park. At each station, you roll the dice to learn what your family's quest will entail, and then you come back to the visitor center and collect prizes. So 10 to 2 p.m. on Saturday, free entrance. Check that out if you are so inclined. And there are other programs happening as well. Check the National Park website for that. All the standard hawks, hikes, and there's a hawk talk, and then we'll get into what's happening next week. There's no other volcano talks next week here.
Sounds like a fun little poker run that they have set up there.
Yeah. So that's the community corner for this week, and that brings us to the end, Dane. We can say our thank yous or whatever,
all right.
Whatever else.
Yeah. I appreciate everybody that tuned in today.
Oh, are you? Oh man, this is the thing we check. Okay. Alright, sorry, I'm not sure what happened there. I just jumped off.
Yeah, that same thing happened last week. There's something happening there with OBS, but can you hear me now?
Looks like you're going through on my monitor. Whereas somehow your monitor vanished from the previous scene while you were mid.
Yeah, I have no idea.
There.
Okay, we're good. So want to thank everybody that came through. We rely on viewers like you to help get this information out there, recognizing the authenticity of it, and helping us just share it as widely as possible, and helping with the algorithm, with the likes and the subscriptions. Appreciate all that. We also wanted to recognize 2 super chats that came through. Skagit Ed with a returning $20 super chat. Appreciate that support there. Says thanks for the steady coverage. Waipod, aloha, and mahalo. We also had a $20 super chat from Catherine P, who's just $20, no comment, and I appreciate that support there. We also are supported by the County of Hawaii through the VIVI grant program, which helps pay for this type of continued coverage and especially the blue skies operations and all the things we try and do to prepare for the next eruption. So we really appreciate the County of Hawaii on that one. And I think we only have, I don't even know if we had a good question or one that I didn't answer in the chat already.
Oh, sounds
Well,
good.
quick. Yeah, I think the thing is where's the betting pool looking like on terms of this thing reappearing? What's the over under?
Yeah,
What's the over under? 3 weeks?
I'd say less. Maybe 2 weeks or 1 week, somewhere in there, week and a half.
All right, so we'll draw the line at 2 weeks and tell us in the chat if you're going over or under.
Maybe
on that 2 week long.
1.5, huh? Maybe.
Okay, yeah, 1.5 weeks. We'll say. All right, appreciate everybody. And that will be it for me. We will be back next Thursday at 5 p.m. Unless something happens, we may go live for that. If it doesn't, same time, same place, Hawaii Standard Time at 5 p.m. right here on Hawaii Tracker and Hawaii Pod. And see you next time, Phil.
Mahalo, Dane. Thanks everybody for donations. From HawaiiTracker.com, he's Dane DuPont. I'm Philip Ong. Aloha, everyone.